our chat. And so looks like people found that interesting, which is great to hear. Started in Europe almost 10 hours ago at this point. So there was some time to gather questions. We have people with us here. We have people joining YouTube and watch live parties in different parts of the world. So from wherever you are joining now, welcome back. And I think we can kick it off with Kelsey. Do you regret anything you said in the previous talk?
No, for what?
No, 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 no. Um, cool. I think one of the first questions that we have, and please feel free to shoot questions at us. I'm getting questions also from the YouTube streams here. Um, the first question that was coming up most, where will platform engineering be in 5 years? Let's start with that. And what can we do now to prepare for that? What are the big themes?
I mean, look, I think the biggest thing is we know this stuff isn't evenly distributed. 10 years ago, the likes of Facebook, Google, you name it, they have these world-class infrastructures that people still only dream about in 2024. And so if you can just get to where Google was 10 years ago, you will be in a really good situation. So I honestly think where we'll be in 5 years is there will be more options for sure. There will be, I guarantee there will be more purpose-built platforms, Lambda, Cloud Run, something based on Kubernetes. We saw things like Run AI. There will be a ton of these purpose-built for the workload type platforms. My guess is we just celebrated Kubernetes' 10th birthday a couple of days ago. A lot of those platforms will probably be smart and layer on top of Kubernetes, just like the previous platforms layered on top of Linux. And so my guess is in 5 years, there'll be, I don't know, 10 new workload specific platforms you'll use to make life easy. My guess is that declarative API, that Kubernetes style. I know people hate YAML, but the truth is, how do humans specify what they want from infrastructure? You have to do it in some data format. So if it's not YAML, pick something and you'll express yourself that way. So those are my two big bets for the future: more purpose-built workload abstractions, and you'll drive them do truly declarative interfaces, kind of like what we see with Kubernetes today.
Okay, so you don't think that this is going away? We're not going into a world of, I mean, because this is like an interesting question, right? You have with that increasing support from language models, we will probably see. I mean, it would be interesting. What do you think about it? But we will probably see even more software be built, just like we saw with the creators movement on the media side. And this software will be more tailored to the process, so more specific, tailored software. But you say, hey, this will in 5 years from now still be, declaratively built and essentially it all lives and starts and breathes in code, right?
Um, so everything needs an API, right? So the way I think about this is we already have hints from the past. There are a couple of CPU architectures. That's it. But we have lots of programming languages, right? So the hardware evolves very slowly. It has to be backwards compatibly, has to work with the electricity we have, it has to work with motherboards, it has to work with DIMM chips. You can't change hardware dramatically without changing every other layer above it. And so then we only have so many operating systems. 30 years later, we have three major operating systems: Linux, Windows, and Mac. That's it. So if you want to bring another one, it's going to take you a very long time to get to where we are now. Now, the tip of that layer, which is like this infrastructure layer, as far as I know, all the workloads still need the same CPUs. All the workloads still run on the same operating system. So you can't go too far from where we are. If you want to make something new, Kubernetes has a 10-year head start. So whatever you build right now, Kubernetes is the new bar that you have to reach. So my guess is there's not going to be a lot of room to start over and attract enough users to make it worthwhile. So what do we do on top of this? We're going to have new abstractions, Lambda, you name it, just doesn't matter. Now this is different. I'm also separating the tools. If you're going to have a platform, you have to have an API. The old way, REST API, right? Get, put, set, blah. Those only get you so far because they're very low level. What we're doing now is workload APIs. It's like Kubernetes is like the first real attempt at saying, here's a pod, here's a cron job, Here's a machine learning job, right? So we've had a taste of that. And what do we do normally in programming languages? We come up with standard libraries. So then you end up with things like Swift UI. You end up with Node.js's Express. This is a current trend that we do. So we experiment with low level. To me, Kubernetes is very low level. Pods, containers, these are low level primitives. And then the SDKs show up, run AI, you name it. But that is very different than the tools you use to program and manage all this stuff, because I also separate workflows. The thing you check in, the thing you code review, permissions, gates, branches, those are very different than the target platform you aim at. Puppet Chef Ansible is very different than Linux, Windows, and Mac. So that's the way I think this is going to evolve. And I don't see a reason to go backwards and start shipping platforms with no APIs like that. No one wants that, right? And then what we've learned from config management, tickling a bunch of REST APIs and gluing together workloads yourself doesn't make sense. The ownership is messed up when you say, hey, make this VM. No, there's a VM workload, and I need to be able to declare the VM and pass ownership to the control plane. I don't know if we're ever going away from that again, because we're only halfway there.
That's an important point, right? The enterprise, like these tankers, they move slow. We're enough, and we've really just scratched the surface on the adoption. One question that we got here from Vladimir, and Vladimir, do say if I'm misinterpreting this. Would you say platform engineering will splice itself up in the future, where purpose-built platforms you just mentioned would be an overlay of generic infrastructure management platforms? How do you think about that?
Yeah, you're an infrastructure team, and your team says, we want to run an app. That doesn't call for you to start over from scratch and build out a scheduler, a workload abstraction. What are you doing? This is highly irresponsible. Now, you could, but I think a lot of people are just going to start where we are. So when I write new code, I start with a standard programming language with a decent standard library. I don't go off starting writing database drivers from scratch. There's pretty good database drivers out there. So in my opinion, if you're a platform team, we already know how this works. You're going to have like 8 type of workloads, maybe 10 that you're going to have to manage. One team wants to use Salesforce. You're going to configure Salesforce, make sure that it works, protect the data. Some teams are just going to care about things like Snowflake. That will be one of your data platforms. So I don't think there's going to be this idea where there's going to be one golden universal platform. That's out. And so I think we said this in the talk. Your job as a platform engineer is to take what you can buy and then do what's necessary to make it useful for your particular team. So if you can get an off-the-shelf platform and just use it, congratulations. Go do something more important. But if you take an off-the-shelf platform and it doesn't work for your company, then platform engineering on that specific platform will be the gray area between what came out of the box and what it takes to use it. That's the job.
Yeah, absolutely. Cool. Let's go a little bit into the practice area and sort of the applying all of this. And that's what I am currently getting a lot. The hype train has started and everybody wants to do it, and very, very few people have done it in the past. So you are the stereotypical enterprise somewhere in the world. You have, let's just pick a number, 500 developers. You are on the cloud now, and you want to get into platform engineering. How would you start building such an internal developer platform? What would be your personal first steps?
First step will be document what you already have. Whatever you have is your 1.0. Stop pretending, stop playing games. That is your 1.0. You may not like it. It may be ad hoc. It may have grown organic. This is your moment to take a retrospective and draw that thing out. So maybe there's some Linux there. Maybe there's some shell scripts. Maybe there is some Puppet. Maybe there's some Cloud Foundry, whatever it is. Try to get the big picture of it is, put it all on one whiteboard, and you can even give it a name. When I was at Google, they called it Borg. Some people call it Kubernetes. Some people call it whatever. But this thing is your starting point, and it's the thing that you got to support whether you like it or not. The mistake people make is they try to ignore what they currently have, bring in a new thing, and then pretend that they can just move everything to that over time. And that's the problem. So if you start with what you have, then you go look at the layers and say, hey, all right, this is our current platform. Where should we invest? And just draw a roadmap. Just add time to the equation. Here's what we currently have. Where do we want to be in the next 2 years, 6 months, 3 months? So let's say in 3 months, you say, you know what we want to do? we want to finally have a build pipeline for everything. Great. Because I think having a build pipeline for the artifacts, the things that actually get deployed, is the precursor for all this other platform engineering work you want to do. It's hard to bring in a platform like something that can run apps and process data if you don't even know how to package your apps and get them deployed to that thing. So most people mix those two things at the same time. So in the first 3 months to 6 months, are we even mature enough to get everything to at least a common artifact, whether that's a Docker image, an RPM, or WAR file, doesn't matter to me. You can have all three. But once you have all your artifacts sitting in the repository, then I think it becomes easier to say, some of our workloads need Lambda. Some of our workloads just need a VM. It's okay. VMware is fine. GCE is fine. And then when you start to look at the output targets, then you go shopping for the buy versus build. Do we build our own custom thing? Or do we go look out and see what's available in the open marketplace to say, hey, you know what? Let's just build on top of that. It gets us 80% there on our roadmap. And then we'll build custom stuff on top, ideally using some extension API, but after giving feedback to the vendor to make sure they can add the hooks that we need.
Yeah, Manju at Gartner calls it build and blend approach, which I really like in a way of looking at this. So that means first do your homework, make sure that you have that lowest level of maturity from which it makes sense, which means you're building artifacts, you have build pipelines, you're doing this. Then once you have that, how do you one of the real problems that I often see, people are trying to do everything at once. How do you get that prioritization right to say, okay, we're going to focus on this, and that's something that's achievable?
Just finish something. Like, I think everybody overanalyzes too much of this stuff. Finish one thing, just one. I don't care what it is, just finish something. So you say, hey, should we start with our most important app? Sure, if you're going to finish it. Should we start with the one that's the easiest to do? Doesn't matter to me. Finish something. What do I mean by finish? You pick this app. Let's say you have a payments app. Right now, today, you build it ad hoc. Someone creates a jar file, and then they copy it to the server with scripts in a change window. That's what you currently have, no problem. So what does finishing it mean? Finish it means go get a build pipeline. If you have Jenkins, use that. If you have Bamboo from Atlassian, use that. Let's not start over. Your job is that when the source code gets checked in and someone tags a commit for release, you start to be able to produce artifacts in some registry. I don't care what it is. It could be FTP server for all I care. And then QA team can pull those binaries down and run some script to make it work. And you say, look, we now have an artifact way of checking in code and get an artifact. Now, the next thing is, let's say you want Kubernetes. For some odd reason, you choose Kubernetes. Do you need Kubernetes? No. Could you use Kubernetes? Yes. But let's just say you choose Kubernetes. You have to finish it. That means taking that jar file and making a Docker image for it. That means you need a Docker file. What version of JBoss? What other things do you need in your class path? Get the image, have QA test it. So now you have an image in a repository. Now you need a Kubernetes manifest. Create those. Once you do that, I think that's a good V1. You finished it. You went from jar files deployed via shell scripts to now having a Docker image that's versioned, that can be released in a systematic way. And now you have a way of saying kubectl apply using a YAML file. And if you want more than that, then maybe you look at Argo CD, but at least finish it. So now when you go back to do the other apps, you actually have a real blueprint. The problem is when you start saying we're going to do 30% of the enterprise apps, you've never finished one. You don't even know how hard it's going to be before you start setting these arbitrary goals. And what turns out sometimes is that for the 50 apps that run on Linux, this works. But what about the ones that run on .NET and Microsoft? Maybe you need another process for that. And it's okay, but let's get these done and then see what we can learn from these two approaches and then go do something separate for the Windows stack. So that's been my methodology, is get something finished, and then you have at least enough learning to plot your strategy for everything else.
Yeah, that's a fantastic point. It's really so important that reality informs strategy and not your perception of what reality could be, right? So, sitting around and trying to come up with incredible, sophisticated scenarios and how it could look like. I often compare that to if you are platform engineering is a lot like many people that have never used an iPhone sitting around a table trying to design one. And you don't get anywhere. Like, you have to jump and then really feel the pain and then iterate on something that's already there. Yeah, great. Then if we just so that I get that correct, you're saying start with one application, one product team, do that end to end, and then how do you like how do you have sort of a rule of thumb on how to sequence what teams to use, or do you just say, hey, lowest common denominator tech stack, or just focus on all containerized things, or how do you do that?
So I think we can also answer Vladimir's question in this Q&A as well. So he has
Yeah.
a similar question: suggestions and strategy and justifying the investment in platform engineering. You have no choice. This is not debatable. If you have an airport, you have to maintain the airport. So if people want to fly on planes, then you have to have airport. You have airport, then you have to maintain the runways. You can say, what's the value of maintaining the airport? Plane crashes. Do you want to crash? No. So you got to maintain the airport. That's just what it costs to be in the software business. So if your company writes software, custom software that they want to build, then they are now immediately in the platform engineering business. There's no way around it. Why? Because there's no platform you can buy off the shelf that just works 100% with you doing no modifications for it. There's just no platform you can buy with that. It could just be a 5-line shell script. Great. Then that 5-line shell script is your platform engineering. Great. Just have a small team. So to me, the thing is just finish, like define finish. Team, can you finish something? And when I say finish, then you have to be very clear about what team you pick. Pick a team that's ready to go. Hey, do you all have the bandwidth to collaborate with me? You're the dev team. Do you have time to get the build scripts correct? Do you have time to make adjustments? Maybe we tell you, hey, since we pick Kubernetes, we actually need you to do a few things different in the app. We need to tune the JVM when we start running because this thing is going to be getting limited CPU instead of the whole box. I just need to have a team that's going to have at least 1 or 2 people that can collaborate as we do the whole messy try and try again. But I'm trying to have a thing that says we can finish. We can finish. So some people say, hey, we should go do the mainframe. You're not going to finish. You're never going to finish the mainframe. IBM can't finish the mainframe to Kubernetes migration. So why are you even starting with that? Do something realistic. How do you find out if you can finish? There's this thing called prototyping. You get one person from your team, another person from the dev team that you're trying to support, and you own it. Stop doing meetings and sprint planning and all of this DevOps stuff. 2 people, you own it. Sit down, get the app, put the app in a container image, put the app on a registry, stand up Kubernetes, deploy the app. Does that work? Is there any gotchas? Resolve the gotchas. That's your prototype. Use that as the foundation for the thing that's going to be required to production. This ain't rocket science, but what people do is they try to meet their way out of this. We're going to do an initiative. We're going to have a kickoff meeting. We're going to involve 500 people that don't really want to do it. And then you waste a bunch of time. So start small, get the prototype out the door. And as you're doing that prototype, you say, hey, let me try this tool. Let us try this tool. What do we like about it? Maybe do a few demos, get a little bit of feedback before you burden the whole organization with a clear path. I watch people do this with Cloud Foundry. It worked for a lot of people. But there were some people who picked Cloud Foundry before they did any prototyping and said, hey, the whole organization is going to be on Cloud Foundry by 2026. How many apps have you done? 0. But by 2026, we're all going to be on Cloud Foundry. It's like, that's not engineering, that's guessing.
Yeah, that's absolutely it, right? And also, the plane is going to land somewhere, and you can determine whether it's on an airplane or on an air or just like a grass land. And use so you have to really take ownership of that. And I know you do a lot of executive roundtables, executive briefings with executives around the world. How do you explain you're a platform engineer right now? Somebody's heard that thing from a briefing with Accenture. It's your job to go to your boss and say, like, we need to do platform engineering and we need to take this serious. What's the story, and how do they, transport the value for executives?
If you go with that message, you're going to get laughed out of the room. Hey, we want to do platform engineering. I said, I literally don't care what you call it. Just get it done. Matter of fact, why are you talking to me? I have so many things to worry about. I have taxes globally. I have to figure out profit and loss. I got to make sure we stay in business. We have all kind of things. And the last thing on my radar is your desire to do platform engineering, especially after you told me you wanted to do some DevOps. And before that, you said you wanted to do Agile. Do whatever you got to do. Your job is to get our software in the hands of our customers repeatedly. Whatever you want to call that thing, have fun with that. So we're distracting people. What you do is you go and say, hey, listen, our app takes 3 days to get to our customers when we're finished. In that 3-day period, we're losing money. Here's how much money we have lost in the last 2 years because of our current process. So we're losing more money than we're saving by not improving the process. I would like to step up and take full responsibility of getting it done. I won't be doing it by myself. I'll be involving the proper teams, but you can count on me by name to lead it and get it finished. And my goals are to go from 3 days to 1 day. If we can get down to 1 day, then we can stop paying these whatever fees we're paying because we don't have changes in place, right? I did credit card processing back in my career. When a new customer wants to have a different loyalty program that needs to launch on a certain day and you don't launch, and they've already did all the advertising and campaigns and people are buying stuff and their reward points don't show up, that could be brand damage. So you got to be able to do that quickly. If it takes us 3 days all the time, then we have to involve way too many people for a whole week trying to get these things launched. That's inefficient. We can't onboard 1,000 customers if that's the process. So I tell people, here's the friction. Here's the thing that's slowing down the business growth. I promise to do my part to fix it. So what do you get from me? You're going to get it down to 1 day, and we can go from onboarding 3 customers a week to 12 customers a week. That's the only metric I care about. Today, we can only do 3 customers, and that's been true for 2 years. When I am done, you're going to do 12. Halfway to being done, you're going to do 6. If you're an executive, that's all I need to hear. We're going to go from 3 to 12. I don't care what you're doing. If you get 12, tell me where to sign. That's how you approach those. And now for your team, you may describe this as platform engineering because we're engineers. We may need to understand a little bit more about the methodology so we can go learn and make adjustments to how we operate. But those are just buzzwords that I think are good for us. You don't need to leak that to everybody. Just get the job done.
Mm-hmm. Nice. Fantastic. Then I want to, before we go into more technical questions, because I'm seeing them pop up here and we will cover them. Luis Silva there is a recent good trend of including product specialists and thinking into platform engineering. Have you seen this being done well? And do you have any examples where this made a difference to the success of platform engineering? I have a very strong opinion on this, but what's your take?
Yeah, I mean, Google has lots of them. You know, when I was at CoreOS, I was that person you're talking about. When I was at Puppet Labs, I was one of those people you're talking about. I ran the Puppet Forge, right? This is when we added modules to the Puppet command line tool so you can do config management with reusable modules. And I would say the thing that I think a product person brings to the table, their goal is to do everything I just talked about earlier. We have a purpose. We are trying to compete with Amazon, IBM. There's other people selling products too. So what is our product? So when you treat something from a project to a product, there's typically things like profit and loss. How much does it cost for our team to maintain this stack? Or should we just go buy one? How much are we delivering things on time? What is the actual value? So a product-minded focus would be able to articulate to everyone involved what we're doing, how much it costs, and the value it brings. You'll be surprised. Most engineers struggle with this. Most engineers will say, we're going to switch from Python to Rust, and we're going to get much better compile time. Everyone's like, okay, that sounds cool, but what are we getting? Well, it's going to be in a memory safe language, and everyone's going to put their head on their desk because they can't believe you still don't understand that there are things that we need to be more valuable. A PM will know that going from Python to Rust is less important than getting more storage so we stop running out of disk space and returning 404 errors. That's what happens when you have the big picture in mind. When you have the small picture in mind, you start talking about micro optimizations and presenting them ahead of the things that need to go first. I'm not saying you don't do those things. I'm saying is that can't be the thing you lead with when you're presenting to the business to fund the team that you're working on.
Yeah, and we have a saying internally: if we spot a customer who has a product owner or whatever for the platform, the chances of them actually being successful, and that for us means they're still around in a year or two, that doubles because it's so much more structured. They really get things done, as you said before. They are able to actually make the case to the management. They keep the stakeholders aligned. They think about multiple user groups. Yeah, that's a good way of looking at it.
I think for people that forget in real life, like real engineering and construction, when you're building buildings and houses, There's usually one general contractor that knows that there needs to be a foundation and plumbing. They have an idea of all the building codes and permits. They understand how much it needs to cost and to be in budget. And then what they can do is delegate to the plumber. They can delegate to the electrician. And the electrician just wants to come in and zoom in on just the electrical component. But the general contractor knows that all these teams need to work together. They need to be done in sequence. You can't be bringing in, electrician and there's no framing for the walls. There's nothing for them to do. It's just a waste of money and a waste of time. This is what a lot of organizations are doing that don't have that PM function. They have a bunch of tradesmen all saying we're going to build a house and they have no idea what order it should be in. And no one knows how much it should cost. And there's absolutely no blueprint. So just think about this as the glue. And it's very common in other forms of engineering. Makes sense for platform engineering too.
Absolutely. Good. Now we're moving in our questions, collecting them here a little further into, the initiative has actually started. Here's a question from the Slack groups. In our enterprise, we have built several platforms in parallel, competing against each other, more or less. There are different teams with different needs, starting their own platform engineering initiatives. I'm scared this will end up in big chaos. We are investing different standards. What is your advice? What does standardization actually mean if the engineering org can't agree on one thing?
It looks like the world. The world doesn't agree on one thing. We have all these spoken languages. We have all these religions. We have all these ways of doing things. Even a household doesn't agree on what to eat, right? So one person's eating spaghetti, one person's eating pizza. This is how it works. And so I think the thing is to find commonality and you're going to standardize over time. I think the mistake we make as engineers, we try to standardize as if it's done. Even if you did organize the whole organization to agree today on doing everything the same way, one team's going to break out. One team's going to start doing some ML thing that your platform doesn't account for. And what you're going to know is that there's going to be a new branch that forms. What do? Everyone doesn't need that branch. Only this one team needs that branch. And then mobile shows up. What do? Everyone doesn't need to have an Android build pipeline. What do? You're going to support that. So there's no way to get away from having all of these branches. They're just going to grow over time, especially if your company is still kind of engaging with the outside world. Then the outside world dictates the pace. Your team doesn't. So given that, I think the way you do standardization is you do it just like any other process. HTTP 3, Google went solo on YouTube to get more performance. It wasn't called HTTP 3, but they used it between YouTube and Chrome. And they had this protocol that was based on HTTP, got rid of TCP, leveraged UDP, and did a bunch of things for performance. Over time, once it worked in production, the community was like, maybe this should be the foundation for HTTP 3. But then we had to bring in other stakeholders and things had to change to make it suitable. And now we have HTTP 3. The same process will work for you, right? So one team goes out and says, listen, hey, maybe let's reuse the logging stack that we have. We don't need to reinvent logging every time. And also, let's say a team does decide to use like a different logging daemon to capture the logs. Who cares? Whether it's a Splunk agent or a Datadog agent, they're roughly going to have some semantic data that you can solve with a gateway. So I love that pattern of saying, this team maybe clicks a managed service, and that managed service collects metrics via the Prometheus protocol. Everything else you're doing is doing some Datadog thing. Sometimes it's worth the effort to put the if statement. If this packet is from Prometheus, then process it this way. So there's ways to aggregate under the covers, but I think you got to realize that you're going to always have to support change. This is going to come at some point. So again, write down what you have. If you start to see that there's 5 different platforms with 80% overlap, then as an engineer, once you've done the assessment, you can communicate to the teams that, hey, all y'all are doing logging roughly the same way. We propose that we unify the logging layer, but keep everything else separate. And then one by one, you start to normalize. But I doubt you're going to ever get 100% convergence. But I do like the idea of sharing what teams are doing. And when you do find a standard library, make that available. Those that want to use the standard library, great. And those that don't should be the feedback loop on how to improve until they can, or justify why you have 2, if not 3.
Mm-hmm. And would you agree that, there's a reason why the world has essentially settled on a standard, right? And it's Kubernetes for whatever reason, but there are evolving winners. It's not that you have 600 different standards in the world, and that's because people with market power push them, but it's also because the community is adopting, and you'll have the things surfacing that then ultimately wins. And to a certain degree, would you agree that an organization is a little bit like, the world and adopting something. The best will win, but it takes a little time.
I mean, the truth is, there are more people that use VMs than Kubernetes.
That's true.
That's just the fact. So VMs are still the dominant technology. Some people still use OpenStack. Some people prefer ECS. There's Lambda. There's Cloudflare Workers. There's Vercel. I can go on and on. But I do think it's worth paying attention. Like when I want to bake a cake, I don't go and grow or buy chickens to lay the eggs for the cake. I just go buy the eggs at the store. So I agree with you. Once you start to see these standards arise, these are nice off-the-shelf components. So I like the fact that off-the-shelf components continue to get better. I do like to go with an off-the-shelf component that has good adoption, so we're not alone, right? So if I want to go do secrets management, I might lean towards Vault because of its ecosystem, the documentation, the training, the videos, the company behind it. That's how I make my decisions. And I think for an enterprise, that matters a bit more. Some companies are like, hey, as long as it exists, we'll do the hard work to make it work for us. And that may be fine for you. But I do think it's just worth, again, I'm just one of these people at this point in my life where write down what our options are. We're going to make a decision. We're going to try to at least justify why we made that decision. And more importantly, we're going to say, when it's time to make a different decision, we're going to let go of the old one. I think that's the harder part because whatever's the standard today could be considered legacy and dangerous tomorrow. Hey, running HTTP was the standard. No longer should you be running HTTP. HTTPS is the new standard. You need to be willing to let go. Some people are like, oh, it's going to use too much CPU. We're just going to keep with HTTP for now and only encrypt 1 or 2 pages. It's like, that doesn't make sense. Now we just encrypt the whole domain and all of the pages. So I think this is just something where it's going to evolve. Just take an engineering mindset to it, use what you can, justify what you built, and be willing to change your mind when the time comes. You're going to be fine.
Great. Now, if we now move into, we have some questions that are around different user personas. I've always been very vocal in saying, hey, platform engineering is a multiplayer game. You can't optimize the experience of one group at the expense of the other group. There is one group that is, I think, not, especially in the enterprise, doesn't have enough voice share in platform engineering, or maybe it does. Would be interested in your opinion. And we have one question around security teams. So, do you think DevSecOps is dead too? Will platform engineering, should security have play a bigger role as a user persona in the platform domain? And how do you think about that?
When I hear all these names, DevSecOps, DevOps, you know what I mean? It's like someone saying we are the World Cup Championship soccer team. I said, but y'all don't even play soccer. It's like, yeah, but we are World Cup champions. We could just call ourselves that because we are working towards that. It's like, no, that's not how this works, actually. What is DevSecOps? There are things that need to be secured. If you have a load balancer, there are ways to secure the load balancer. Just think through it critically. These things have a config file. There's a secure config for your needs. There are trade-offs you can make where you may say, we can't do the secure thing because it won't work at all. Like if I lock all the doors to my house and throw away the key, it might be really secure. If I get rid of all the doors in my house and just seal it all up, it'll be really secure, but I can't get in and out of it. So it makes no sense to do that. So I think the security team's job is to figure out what the trade-offs will be because there's always going to be a trade-off. Going online is a trade-off. The moment you go online, that's the trade-off. The moment you make your API accessible is a trade-off. So I think when it comes to this DevSecOps thing is get things done. So this is a code word for stop playing around and get things done. How do you get things done if you're in DevSecOps? The team wants to launch an application. You could sit back and tell them, make it secure and present it to us. And once we deem that that is correct, we will let you do it. That doesn't work. People want to get things done. They want to get things into the hands of their customers. Most people aren't doing this for fun. We're doing it because it's part of our job. So if you want to be helpful, what you can do is say, let me look at the app. What is it? So REST API? What do we need to do to lock it down? Okay, this is our problem together. Knowing what I know, there are some things we can do on the F5 side. Maybe I'll learn some Kubernetes so I can also be a second pair of eyes that take a security lens to what you're doing. So you spend a lot of time making the functionality work. Maybe my expertise is security and we can collaborate. So here's the thing that I think is really interesting about some of these modern platforms. when I used to work in security or work with security teams in like 2005, 2006, there was like a SharePoint doc that said, do all these things and you're secure. So when you want to write a new app, we will review everything on this doc and tell you if you pass or not. And then every quarter we would audit to see if you're still compliant. And if you're not, we'll tell you to fix it. In between, we just get hacked. That was just how it worked. But today you can take that doc and turn it into an emission controller in Kubernetes, if that's what you're using. So then instead of telling people that we have it written down somewhere, you literally can say, hold on, before this app gets deployed, you can go do static analysis on the code. You can verify that it's signed. You can go configure load balancers. You can limit what it can do. You can install tools like Sysdig. You can put all these things to limit system calls, run it under gvisor. You can put Istio to limit the network communication very granularly. There's so many things you can do that you take the security policy that was written and you can serialize it into a service mesh, into some workflow engine, into something that's always evaluating. That's what I think it means to do DevSecOps. Just stop talking and start doing. And when you do, in the new platforms, you literally can codify the policy. And when people want the policy to change, you update the code, and that's the new policy. That's what this means. So just get it done.
Yeah, and so that's back to the silo theme, right? Silos are fantastic. It's like security can also be that silo that builds the policy, and you build good protocols between them, and you collaborate only on new stuff. And yeah, absolutely. We have an interesting question here on YouTube, I think. How do we prevent platform engineering just becoming like DevOps? Good for advanced and high-performing teams, too difficult for everybody else. Like, how do we do that?
Start talking about results. If you start talking about results, you can call whatever you want. If you keep talking about this stuff with no results, then everyone's going to say, hey, I keep hearing this thing and I haven't seen results. So this thing must be terrible. That's how it works.
Yeah.
Hey, what are you doing? We're doing DevOps. What's the results? We don't have any. We've been on a digital transformation journey for 10 years. You're lost. So whenever someone hears DevOps, they can get an allergic reaction and say, oh, you're doing DevOps. That means we're not going to get anything done. We don't want to do that. So when it comes to platform engineering, talk about the results and then tell people how you did it. So that's when it struggles, right? Because some of y'all ain't got no results. You have no results, but you still want to talk. That's where you're getting stuck. So what you got to do is say, hey, why are we even doing this? That's the right question. Why are we doing this? That's the goal. Get some wins underneath your belt. Again, this is what I'm saying by starting small. Get any W. Like the first W I got when I was doing what we now call platform engineering, I just got every app into an RPM. That's it. We didn't do Puppet yet. We didn't do any CI/CD yet. All I did was make an RPM spec file for every application. And when I was done, I was able to show everyone that, hey, QA, even though we're doing things manually, you can now call yum install the thing. And everybody's mind was blown because I had now changed how everybody installed apps. It was predictable and repeatable by everybody. And then when we did Puppet, our Puppet files were so small because they were just doing service, like install this thing, service start. I just kept making progress. So no one cared what I called it. So that's all I would say would be the difference. Let's talk about results more and then say we are getting these results because of platform engineering.
Mm-hmm. Yeah, nice. Okay, so let's get into a
hold on. This Owen person. Can I just? Owen's been like spamming this whole thing about Arback and security and Arback and security. Owen, security is a practice. It isn't a finite thing. Period. That's just how this world works. There's layers to it. There is no app that's going to agree on what security means, right? So let's just break this down technically. What is Linux security story? All right, Linux is a kernel. It tries its best to manage processes. Then we have our user land like Bash, and you got these random ass tools. Some of them run as root, some of them don't, right? Then you have things like SC Linux that tries to reverse engineer and integrate with binaries that don't even know SC Linux is a thing. If you get your SC Linux config wrong, then the binary doesn't wrong, right? Like you say, hey, process, you can't access this PID or this socket or this file. Then the app doesn't start. So what do humans do? We turn it off, right? You turn off SC Linux because you don't have time to develop the perfect SE Linux profile. Now, should every binary in the world understand how it's going to run on SE Linux? Maybe, but who's going to do it, right? So that's just the app layer. So let's go to the protocol layer, right? So to me, there's this debate. Should the app know everything about Arback? Should it? Should it know everything about all the users? Because if it did, then you have to update the app every time you want to do something. Or you go to an external system, right? Pick one, build a custom one. It can be crowd from Atlassian. It can be open, open Arback or open whatever you want. Either way, you're going to have roles, permissions, users, credentials. Unless you find a new way of doing computing, I don't know any other fundamentals than those. Where do you want to put them? You want to put them in IAM in the cloud provider? Do you want to pick Kong and put that on the edge? Do you want to use Apogee? Do you want to use Cloudflare? Do you want to do TLS mutual auth? Who's going to rotate them? How do you bootstrap your key management system? These are all things that have evolved over time. And the problem is that the apps have been around longer. And so if we keep trying to integrate these into the app, then they're going to have to support 10,000 authorization methods. So what do we do instead? We do layers. You lock down your kernel. You use tools like gvisor to intercept system calls to make sure the app is running only on the strict system calls that it needs. You audit consistently. You're using third-party libraries you don't understand. So then we try to do static analysis and create SBOMs. And as we go up the stack, we're trying to examine what calls need to be made. Maybe you go with something like gRPC, where you can have a schema to the protocol and ensure the client and the server are doing the right thing, and you drop everything else. Do you use drop tokens or TLS certificates, right? So we have so many choices, and all of these choices have to be backwards compatible. I think that's what makes all this hard. You can't just introduce a new golden security standard and it doesn't work with anything, right? Because it has to integrate well. And if it's already deployed, we're going to make the trade-off to have a working app over a secure app. That's just the reality of it all. And that's the tension, I believe. So I understand what you're saying. It makes total sense. But in reality, security is nothing more but a trade-off. There's no such thing as absolute secure. There's trade-offs. And the more people that are collaborating, the more these platforms that have enough metadata so we can figure out and get to where we need to be, so be it. So that's what I mean by this idea that this is just a practice. We're practicing. And as we practice, hopefully we do get better. And I think frameworks and platforms can help.
Great. Oh, and I hope this helped. Let's do another one on the technical side here from Bob Harwood. Level triggering seems to be a better general design pattern than edge triggering. Do you see applications moving their APIs away from HTTP REST and towards Kubernetes style of API, which adds some non-functional support, X cross-plane? If so, what needs to change in Kubernetes to support this level of demand on the control plane?
So Google Cloud had the same exact thing, right? So Google Cloud has a REST API. Why? Because everyone is using tools that support REST APIs. That's why. You have to integrate with the actual customer base and the real world. Kubernetes comes out. Kubernetes has been around for 10 years. There are some parts of GCP that have a Kubernetes style API, like Cloud Run, for example. You can give Cloud Run a pod manifest with some annotations that are specific to Cloud Run, and this thing will run your serverless thing. Now, the problem is not everything is declared. There are some imperative things like how many instances of a thing to have. So we have REST APIs that say, for right now, make it 3. For right now, make it 5. This works really well with like imperative, non-deterministic autoscalers. Based on this traffic, make this 3, not a range, 3. And so you end up with this combination of APIs. So what do I kind of advise people? Kubernetes is a top-level API design. So you have a little control loop. Ideally, the control loop can own every part of the lifecycle of the thing being configured. And if it can do that, then yeah, you can give it a REST-style API. If you think about it, Kubernetes is a RESTful API. It just happens to be this thing that's modeled in a certain way. And I think that makes Kubernetes special with the status field. Honestly, that's probably the thing that makes it the most special is the status field, and the version is in the payload, not the URL. And it made it easier to have this declarative thing because you can ask the declarative thing for the object, and the status was part of the object. That is a game-changing semantic here. So I think the big advice here would be in your controls loops, your automation things, they need to own the whole lifecycle of a thing. So if it's a VM, then ideally you probably want this VM type to be able to own the volume. I know it sounds weird, but if you don't have it own the volume and another control loop owns the volume, then clients are going to have to do their own orchestration, and it's going to feel weird. You'll make one REST request to create a storage volume, another request to make the VM, and another request to mount it. It gets real tricky, doesn't it? But when you have a workload API design, whether it's Kubernetes style or not, then what you're saying is that I am going to do the thing that people say you shouldn't do, which is munge these individual things into a workload type so that your user experience can be holistic. And we've been taught in the REST world that volume should be its own type, VM should be their own type, and now you leave orchestration to the client. Kubernetes flips that around a little bit. Kubernetes says, when I say a pod supports health checks, apps, volumes, secrets, and all these other things, it does it holistically. So it can manage the entire lifecycle, including the right ordering. So you don't have to think about it. So that's the big difference. So we're going to do both, but just understand why we have both. And workload APIs are just an abstraction on top.
Fantastic. We have one here. Lots of platform engineers focus on multi-cloud. Yeah, I'm actually seeing that a lot. Does this mean platform engineering will end the era of dominance of the primary cloud providers? Do you think that will have an impact?
No, because we already have history. If you walk into a data center, it's already multi-vendor. There's NetApp, there's Oracle, there's HP, there's Dell, there's Cisco, there's Juniper. These things are all different, and they all have APIs. And so what do you do as a platform engineer? You don't call it multi-vendor, do you? You just work with the various APIs and you try to create an automation abstraction so people don't have to think about those individual components. That's it. The only thing we did with the cloud was we put a big ass network between the two stacks. That's it. In your data center, there's an Ethernet cable between NetApp and your HP ProLiant Blade server. You don't treat it any different. And so to me, I don't know if cloud warrants this overthinking. The thing that makes cloud hard is, and I have empathy for it, they just have different APIs. They have different workflow engines. They have different authentication methods. They have different pricing models. And there's a huge network fee if you try to communicate between those two cloud providers and their boundaries. So it gets a little sticky. But I think it's the same. Your organization, remember the change thing I said? Your organization is going to use what's necessary. So you're all in on GCP. You're super happy about it. Amazon or Microsoft announces Open AI. Now your company wants to use Open AI, ChatGPT as a foundational part of their app. What are you going to do about it? What you're going to do is you're going to go create an Azure account. You're going to get your credentials, and you're going to have the apps in GCP for the time being communicate to the OpenAI API endpoint. Is that multi-cloud? Sure. Does it matter? No.
You said Open API. It's the 10th of June 2024. So I have to ask the question, otherwise I get crucified. What is the role of language models, call it AI, whatever, where you want to call it? Like, will that have an impact? Does that have an impact on the design of declarative approaches, infrastructure as code? Like, is this a self-driving car problem? What will we see?
I'm going to answer that one in a second. Owen, back to you. Owen, you have the ability to rewrite all the software in the world to add Arback support. You, Owen, you can go to every GitHub repository, fork all the projects, and add granular Arback support. You can add it to grep. You can add it to Vim. You can actually add Arback for every buffer that people have to authenticate before they can read a buffer. You can totally do this right now. The thing is, who is going to go back and add granular Arback? Arback is very hard, by the way. I don't think people understand. Arback, this whole role-based access thing, like Kubernetes had to do this inside of the core, and it took years. And I don't think we even covered every aspect of Kubernetes via Arback. It's very high level. This user in this group can access pods in this namespace. That's about as far as we got. I don't even think we have things like this user can see this field, right? So how deep you want to go with Arback? And these are the type of decisions that have to be made and maintained forever. And there's probably what, at this point, hundreds of millions of software. So who in the world is going to go and agree on what the schema is for Arback, and then what the right control engine is for that? So if that's you, then you got to get started, because my guess is that's going to take you about 10,000 years, assuming that everyone stops writing new software now. So it's not going to happen. So the best you're going to do is you're going to wrap controls around it, and that's just reality. I just wanted to address that because I think a lot of people, it's easy to say things aren't secure. So the question is right back to you. So what are you going to do about it? What are you going to do about it? Because that's not my sole responsibility. It's not one vendor's sole responsibility. The question is back on the whole community. What are you going to do about it? So my work inside of Kubernetes and the Kubernetes community, they added Arback into Kubernetes. It's far from complete, but it's there, and there's a foundation for it. And where we got some things wrong, we added emission controllers so that those objects, you can implement your own fine-grained Arback thing to say this thing can either run or not run. So there are ways of doing it. Some tools add hooks. Some tools are yet to add those hooks. So congratulations, there's a ton of work to do. Now let's get to the AI component. So when I look at the machine, so I separate, so AI is really interesting because AI has been everywhere for a very long time, like your Google Maps, finding the shortest path from 2 points to another. There's AI, there's ML, there's so many techniques inside of this that's there. But ChatGPT has brought on a new found resurgence and interest. Like, ooh, one day we may be able to talk to our computers like we talk to each other. We prompt each other, hey, I would like a flight to Paris. That's all I have to say. And the airline employee knows where they work. They know who I am because I gave them my driver's license. So their context window is pretty great. And then what they can do is take that small prompt and give me a ticket. And I can just go and sit on the airplane. That's amazing, right? And a lot of things have to get programmed to make this work, but I didn't have to do it. So it's great. Airplane is still the same. The itinerary system is still the same. TSA is the same. Security lines are still the same. But we got this nice automation. So what are people excited about? Today, if you were to use, let's say something like Terraform. Terraform allows you to write HCL and you point it at the cloud APIs and you hope for the best. Create this VM with these volumes in this region, with this CPU, with this memory, right? You get to lay it all out. So if you know HCL, then you can articulate the configuration for the cloud provider. Sweet. And the nice thing about HCL is that it's symbolic programming. It's deterministic to a degree, right? When you say I want in this region, it's not predicting the region, you're telling it the region, right? And so sometimes you actually want that. Sometimes you want to configure things to be exact. So let's go to the thing where you don't know HCL. I don't know HCL, but the team is doing configuration as code. They want to make sure that we're starting to use things like Terraform, and I'm starting from zero. It is nice to say, I would like a virtual machine in the region where my database is. And so this thing will go and look up where your database is. So maybe you're going to have some kind of knowledge source of truth because it's not going to be able to guess that. This thing is not that smart, folks. It still needs a lookup table or some database or some backend or some RAG implementation. So it says, oh, I found your database. Maybe this is the one you're referring to. So it's going to guess. And if it can't guess, it may just make up something. I think this is your database in US East, even though you're in Europe, but I'm going to guess. So it brings in that. And then it generates what it thinks a VM should be. Is it the right VM? It doesn't know, and you don't know either. But at least it generates that first draft, which is magical, right? So you've seen this before in your life. It's like a template, right? Some ops teams create templates where you only need to know 3 variables. And we didn't call them prompts, but they're just 3 variables. So you gave it enough information so that we can fill out the templates. So a lot of people, this stuff will feel like a better templating engine because it's not static, right? It's like it can dynamically generate. So the generative AI part, it can generate. The problem is the way it goes about generating. It's guessing. And so it may generate the HCL. You're like, oh, Terraform apply. Oh, it works. But it may not be right. You don't know, and it doesn't know, but you think it's working because it compiled. That's dangerous, folks. At the end of the day, when we talk about platform engineering, we're trying to make decisions for our organization and serialize them into the platform so that everyone else above it only has to deal with a limited set of variables. So even if you use ChatGPT and you do it correctly, it's going to feel like the same thing. Those prompts will just get parsed into a set of variables. They'll use the exact templates that you want the organization to use and eliminate the guessing. So the way this is going to look is if you're in ML ops and you come up with a nice model, that's the thing we haven't talked about. You have a model of the world in your mind, and that model of the world allows you to articulate it into Terraform or Puppet or Chef or Ansible or any other platform, right? So now you got to take that thing out of your head and you're going to try to give it to these tools so they can use that as a knowledge agent to generate the right thing for people. And so I would just use it as a learning loop, first draft mode. Maybe you tighten up the model so that it's predictable a little bit more. People are getting what you want them to get. But I look at it as a signal. The current interface we're using for this stuff is terrible. Puppet, Chef, Ansible, YAML files, XML files, 7,000 different config languages. No one can keep the entire model of all of these things in their head. And what we want is that workload API. This is why things like Knative and serverless felt so attractive, because they collapse all of these domains into one simple workload abstraction that only needs a few variables. And so my guess is we'll use this AI stuff to deal with the ugly world that we currently have. We'll learn from that, and we'll just build better APIs that abstract it away. So you automate until you can abstract, and we just keep in this perpetual cycle to the point where the API is so clean, you won't need our generation for what? The API would be too detailed. We just put in a few variables and off you go.
And it's really like, yeah, it's really like the self-driving car problem, only that, the turns you're making there are turns you're going to make for the entire life cycle of the resource. Like, and you're crashing into something, you're going to crash for the next 2 years. And it's going to be very hurtful. Yeah, that's a great analogy. Now, as a last question, let's take this one here that we just received on YouTube. I think there are always the early adopters who hop on, including business leaders who see the savings in terms of agility. But beyond that, how do you drive platform adoption more quickly upon the larger middle standard deviation of users? And lastly, the laggards. If agility is the carrot, is there a stick you recommend, see commonly used? So for instance, cybersecurity needs, compliance, any of that.
I'm going to just speak from my personal experience. When I worked in financial services, highly regulated, decades of prior decisions, mainframe, IBM, working software, maybe people didn't like it, but they had it. So the new guy shows up. What are you going to do? You're going to make people do it. You're going to shame them into doing it. You're going to say buzzwords loud enough that they do it. I just got things done. So I said, listen, right now, it literally is taking us every week to deploy software. We start at midnight and it goes to 6 a.m. It's such a painful process. No one wants to do it. So then what do? I could walk around and say, hey, Red Hat RPMs, Puppet config management, DevOps. Or you can say, what if I could allow people to pick apps from a Jira drop-down menu, and if they hit save, they can review the ticket using whatever change flow process they want. And when they hit save and they pick an environment, and they can even pick the server to be specific in another custom drop-down, the automation will run underneath and just update the ticket until it was done. QA would verify it and close the ticket. What if I could do that? Then they can deploy anytime they want. If they're more comfortable deploying during the day for dev and QA, they just had to open a Jira ticket. The Jira ticket was necessary because it was a highly regulated environment. They wanted someone to approve every deployment in every environment. I don't need to fight that. That's a thing that they've justified for their business case. I just integrated with it. So when I was done with that particular project, guess what? Puppet is under the hood. We were doing pixie booting, VMware images, using link clones, all of this magic so we can speed up the whole process and delete them when they were gone. Less interesting than the fact that I just had this live demo. So to me, the carrot is just to show people, here's how we're currently working. And I always do that because I want to show people that I respect the current process. I've took time to learn the current process. And I'm not just ignoring it, because sometimes you miss the good parts of what is already there and you recreate something without understanding why things are there as they exist. So I always start my demos with, here's how we currently do it. And everyone's like, oh, Kelsey, you took the time to learn mainframe, COBOL, and how we're doing those? Yeah, I had to. But once we've done that, I learned a few things. So I'm going to show you this other way. And I know we have to open Jira tickets here, but you notice that there's two custom fields. If you open a deployment ticket type, you're going to get these custom fields. They're pulling from the RPM database. They're pulling from the servers running in VMware. So they're always up to date. And if you hit the drop down, you hit save, it does all this stuff for you. Now let's log on to the server. You see that? Let's delete the server and try it again. It works. It works. It works. That's where we can go. And then people see that and say, yo, I want to work that way. And then they're willing to learn Puppet and support all these other things. So that has been the way I've gone about it in any context. Learn the old way, show the new way, meet people where they are, but then show them what's next. And if you do that, then the team can rally behind something that's real.
Great final words of wisdom. Kelsey, we have to get to the next talks. Thank you so much for spending so much time with us and have such an engaged debate. Thank you, Owen, and everybody else. And see you soon somewhere in the world. Thank you very much for being here with us.